And we saw that in number 7, what we were doing was to print the results. Actually, we print the result in two ways. And in the first ways, we just went through with the first cycle through the data and print on the screen. In the second way, we actually take the data, store into an array, and then read the data again from the array and print on the screen. What we do now is to write our results to a file. In this sense, having the operation we did before was functional to this scope, because if we didn't have stored the data in this vector here in some v, we didn't have the data for writing it. So here actually I store the data and I print again the data, but this operation here was storing somewhere the data was functional to what we are doing here. And so, writing the data from a file, my reference is this one, which is Java write to a file. Actually, the website here gives at least 5 ways different ways to write the data from a file. There is an accumulation of classes that can do these things. First, we are exactly here, actually. One thing that we have to do is to change this one and put the name of your output file here. Here I put my, assuming that you have already run this program before as I did, the strange thing would have it that you created a long file with this name here somewhere. Instead, if here you declare the directory in the correct way, you will have a file called simple output file.txt. To manage the file, we already saw before, and there is a file class that takes care of managing the file. And so I instantiate a new a new file object called output file, and with the name uses Ricardo Dropbox A minus less workspace Java 2019, which is actually 2018. I don't know why I put 19, but okay. Because probably I want to finish, my planning is to finish data simple output file .txt. Let's see which methods output an object of type file contains. One important method is exists. This method says if the file already exists. So if the file, because if you already execute your one common thing is that you are doing simulations, you are running, you are doing experiments, maybe not in the case, you are running your experiment. Then you say, okay, I want to change the parameters, but you don't change the path files. and you go and overwrite the files that you already have written. So here I am just implementing a simple strategy not to overwrite the file. I just look if there are if the file that I want to write is already there. If it is already there, I rename it. I rename it like old with the extension old. So each time I am creating a file with the same name, which happens here very often because I have fixed the name of my output file, I create a dot old. So if I do something wrong, in principle, I can go back. I have one option to go back and save the file. This tricks was very useful in the past to me. So I think the other thing is not output file is a directory. Is a directory is a method that return a boolean, as you see here from the what Eclipse suggests. And you see, it is 1 if it is a directory. And it is 0 if it is not a directory. Here I say the file exists and should not be the name of a directory. Otherwise, if it is the name of a directory, there is no conflict. So I rename it, and I have output file. It's just a method that does the work that I want to do. And says I have to declare new type of file with this name, which I had .old. And what this operation do is create a new file with the name .old and transfer the reference to the old file to the new created file. So now I am ready to write to the file that I desire. Get name is another method of the file. It gives me the name of the file I am writing. In this case, output file get name give me the name of the file of the output file, and I am writing here. Then for writing a file, what I am using is a buffered writer. Buffered writer is a class which is similar to buffered reader, meaning that I have to open a file writer in this case, and then I give it in as input of a buffered writer. So I declare a buffered writer named writer. Here I have a string hello new file, and buffered writer requires to throw an exception. So here I have to try to put try and catch. This type of information usually is easily managed by the ID. So Eclipse, if I don't put this try here, Eclipse suggests me to put the braces or to add at the beginning here an exception throw. Let's say public class main B throws, and here we are IO exception. Okay. So first is the decorator pattern. Writer, new buffered writer, new file writer, output file name. At this point, we know that there is no anything with this file name. And then it's very simple. Writer, write. and I write first the string hello new file. Now I have a vector of doubles then for each double in the vector of double sum v, I write the value here, and I add a carriage return. I go to the new line. I don't know if I mentioned to you in previous classes, but here it is easy to see that the plus sign here is specified to strings. When you use the plus sign with two strings, you just join the two strings. As with the scanner, when you open a writer, you have to close it. And that's all. That's all. If you go here, you say, okay, here I put the simple output file thing, and if I go to open it, open file, you see here I have a simple output file .txt.old, which is the previous file I had that I have overwritten here. And then I have the simple output file which I can open. And you see, hello, new file. This is 12, this is 24, and this is the other sum. Maybe this is not enough for being so explicative, so I can say, hello, output file. This contains the sums of simple input file, maybe I call it simple file. Simple file txt data. That's a simple correction. Now you execute again. And say, this file has been changed. And as you see, I can upload the changes. And I have here the second command. Okay, here I did a small error because here it is missing a carriage return. So I go here and I add the carriage return. Now I execute. Go again. Now it works like it has to be done. So do you have questions? Otherwise, we can say that we have finished for today. So what we saw here is how to read a simple text and how to manage it. Still here, okay, we used these get parameters. We actually read a simple text, and also we translated the text into data, in particular doubles. The way we did it was just to add all the stuff in the main. So it's not really what we want to do, but let's say I often use to do like this because many people take a blank paper and design what they have to do on a white on the paper. They draw the classes. They decided they use at the end to do. That's at the end the right way to do the things. But sometimes you have to experiment different solutions. So you have to do, and this I prefer to do in a scripting way, like like this one. So here, essentially, I experimented several solutions that I choose some solutions without taking care of how to organize actually the code in a better way to be also reusable later on. In fact, what is the next one? I don't know, maybe if we look at, well, maybe we can we can go if you resist, but I have no, I have 10 minutes, then I have to another class actually, so I can do. But the intermediate results, you see, compare this code here with this code here. The only difference is that in this case I move out most of the how-to to a class, in particular to get parameter from a file one or get double one and so on. But we and so here the code is very more readable. It is say here I have the data that I put here. Say, oh, get a new double zero. Read the size of the data. Read the data into strings. Skip some lines. Read the number of data, get the double, and then print the sums and write the sum. It's not still perfect actually, because the name of what I wrote here a little bit remind the operation that I did before. Maybe the name here can be a little bit tuned better to be better narrative than they are, and more give more expression to this file to explain better what I am doing. But I say that the difference from here to here, you can from B1 from B you can appreciate. And actually, this is more or less the same. The result that the final user has to, in case to manage, in a sense, not the final user. In case this is a programmer that is using your libraries, but yourself, when you do this type of abstractions, you wrote the libraries, which is get double zero, and essentially that one. And then you you don't care to or the rest of the how-to. You just do the things in using the whole stuff, and you can do several as many times as you want in different programs. Differently here, you have just one program, one task. You don't have any reusability here of the code itself. You have a reusability of the concepts maybe, but not of the code. So next time we will see better B1, and then we go to C, and then to D, and then to E. Bye-bye.